Hello, this is Mr. McGovern, and welcome to the fourth video in the series on two-dimensional collisions of NCEA Level 3 Physics. So we're going to spend about 2 or 3 videos looking at the centre of mass. So we need to, in this video, just describe what is the centre of mass, and then why do we even care about it. So the centre of mass is being able to simplify a complicated object, like this runner here, down to a single point. And the centre of mass, the really important part of it, is it's a position. Okay, so you can't just put the point anywhere. The position is important. It averages out all the parts of an object, all the atoms of an object, or a system. Remember, a system, it can be multiple objects. The centre of mass, which we call the COM, you might see it written as, and in some books they talk about it as the centre of gravity as well, but it's the same thing, centre of mass, centre of gravity. It's the position on an object where the force of gravity acts. So if we were to draw a force of gravity acting on this runner, the exact point that acts on is the centre of mass. So why do we care about centre of mass? Well, it turns out that you care about it already. You already use it. Objects have many, many moving parts. Like this runner here that is pictured has her whole body is moving forward, her legs are moving up and then forward and back, her arms are moving forward and back, her head's bopping up and down. There's lots of moving parts within this one person, but it's much easier to deal with this as a single point that moves along. So you already would deal with this situation. You wouldn't even think twice of saying, this runner moves at 10 meters a second. The reality is she doesn't, because her legs are moving at one point faster than that, while one of her arms might be moving slower than that because it's moving back. But at 10 meters a second, if we're the way you would normally describe the runner is really describing her centre of mass. You've simplified her down to a single point, and the cool thing about this is it's just as good at describing the physics. So given that the centre of mass moves at 10 meters a second, you could make a prediction of when she crosses the finish line, and your prediction would be very accurate, considering she's made up of all of these complicated moving parts. The second reason to care about centre of mass that's really useful is to look at whether objects are stable or not, whether they're going to fall over. So if you take the centre of mass and you draw a line directly downwards, you see where does that line go through what's called the base of support. Now in a car, the base of support's easy, it's just between the wheels. So the green car there, they've taken the centre of mass and they've dropped a line directly down, and you see that red line falls outside of the wheels, so that car will topple over. Whereas the blacker car has a lower centre of mass, or centre of gravity, they've written it, and because of that, when you drop the line directly down from its centre of mass, you see that that line goes between the wheels, and so that car will land on its wheels, it won't topple over. And the same with the buses here. So the bus is fine in the first diagram on the left because the centre of mass, the line dropped down goes between the wheels, but in the second diagram, the line dropping down goes outside the wheels. And so the bus will topple over in this case. And the third reason we want to care about centre of mass, it's a really useful way of analysing systems. Now remember in level 2 when we met systems, a system is a fancy word for dealing with 2 or more objects at once. So the classic system is an Earth moon system. We can simplify that down to a single dot or a single centre of mass, and we can do calculations on that, and it's pretty accurate. But a system could be a runner holding a baton, okay? Because there's two objects. There's a runner, and she's holding a baton. It can be multiple objects, and when we deal with them as one thing, we call that a system. And so centre of mass is really useful for that as well.